We're here asked to find the first four Taylor polynomials for lnx. Now lnx is the natural log or log to base e of x. Another way to write lnx, log to base e, about x equals 1. So where do we start with this? I think the first thing is to write down the rule for polynomial in x. So we want the nth polynomial, so we're writing the general rule down. So from k equals 0 to n, f the derivative, so that'll be k of a all over k factorial x minus a to the power of k. Okay, so that will generate all the polynomials we need. We want the first four, so we'll work up first, second, third, fourth, etc. What else have we got? We know what is f of x, so we've got to look in that question, see what is f of x, and f of x is equal to ln x. And the other thing we need to be able to write down initially is what is our a value, about what point do we want these polynomials. And about x equals 1, so a is equal to 1. So that's required to be able to identify each of those from the question. Now, previous examples I've done x has been equal, the a value being equal to 0, so that's why I'm going to do this one. It's a little bit different. Okay, so we want the first four polynomials, so we're going to have to do the first four derivatives. And so let's just start with that. So the first one is f of x is equal to ln x. So this is a general way. So we're going to go f of x, then f dash of x. So it doesn't matter whether you go this way or you go down this way. And so f of 1 is equal to, now that's equal to the log of 1. And you know that, what's the index? You've got to raise e2 to get the number 1. Well, that's, you've got to raise the power of 0. So what is f dash of x? So we're going to find the first four derivatives. F dash of x, what's the derivative of ln? And that's 1 on x. Another way to write that is x to the minus 1. And when we put f dash of 1 in there, we're going to put 1, so 1 on 1, which is just equal to 1. The second derivative of x, which is the derivative of the first derivative, what is the derivative of x to the minus 1? Well, the minus comes down, and then you take 1 off, so it'll be minus x to the minus 2. So that's minus 1 over x squared. And if you like, you might like to write it like that as well. And f, the second derivative, with 1 in there, is just equal to negative 1. F, the third derivative of x, so f triple dash, is equal to the derivative of that. Okay, so the negative 2 times the negative 1 there will be a positive 2, and then you take 1 off the power, so that'll be x to the minus 3, and we could write that as 2 over x cubed. So f third derivative with 1 in there, and we get, what do we get here? 2 over 1 cubed, which is just equal to the number 2. And our fourth derivative will be equal to negative 6 x to the minus 4, which is equal to negative 6 over x to the power of 4. So f, the fourth derivative with 1 in there, will be equal to negative 6 over 1, which is negative 6. Okay, now once we've got that, we can then start working through, we want the first four polynomials. So P1 is, we've got k equals 0 to go in first, so that will be f0, now a is equal to 1, all over 1 factorial, and then that'll be 0 factorial. We've got 0 going in first, and then it'll be x minus 1 power of 0 plus, and then we've got we've got k equals 1, so it'll be the first derivative with 1 in there over 1 factorial, and then that'll be x minus 1 because a is equal to 1, all raised to the power of 1. Now f0 is like just the function, so if you like, instead of that you can put f0 that's just the function without finding the derivative of it. That's what the f0 means. So it's just the value of 0. Anything raised to the power of 0 is 1. 0 factorial is equal to 1. So that's 1, 1, and this is equal to 0. So this whole term here becomes 0 plus first function, the first derivative with 1 is just 1 over 1 times x minus 1. So that's just equal to x minus 1. So that's the first approximation, or the first order polynomial, Taylor's approximation for the function ln x. P2 will be equal to P1. We should put an x there. So it'll be just the first order plus the next in the sequence here, and we get f double dash 1 over 2 factorial x minus 1 to the power of 2. What is the first order? It's just equal to x minus 1. Now to work this out, we've got to go back up to what we've done above here, and we've got the second order, second derivative with 1 in there, which is negative 1, over 2 factorial, which is 2 times 1, which is 2, x minus 1 squared. So probably a better way to write that is x minus 1 minus, because that minus will make that plus into a minus, x minus 1 squared over 2. Okay, well, we've got 2 more to go. So P third order will be equal to the second order plus the next one, which will be f triple dash 1 over 3 factorial x minus 1 cubed. So that'll be equal to the second order, which is x minus 1 minus x minus 1 squared on 2 plus, now what is the third derivative with 1 in? It'll be equal to 2. So 2 over 3 factorial is 3 times 2 times 1, so that's 6. X minus 1 cubed. So that's equal to, we probably need to go on the next line there. So x minus 1 minus x minus 1 squared on 2. That'll be over 3. 2 into 6 goes 3 plus x minus 1 cubed on 3. And the last one, P4, fourth order, will be the third order plus the next will be the fourth derivative with 1 substituted in 4 factorial x minus 1 to the power of 4. Maybe if I start here, we get x minus 1. So the third order is all of this, minus x minus 1 squared over 2 plus x minus 1 cubed over 3. Now, fourth order is negative 6. So going back up here, this here is negative 6. So plus negative 6. 4 factorial is 4 times 3 factorial. 3 factorial is 6, so that's 24. X minus 1 power of 4 equals x minus 1 minus x minus 1 squared over 2 plus x minus 1 cubed over 3. Now that will cancel down, there'll be a minus coming out the front, 6 and 24 goes 4, so that minus will make that plus into a negative, x minus 1 to the power of 4 over 4, and you can see a nice pattern starting to happen here. If you like, that's x minus 1 over 1. So there's our first 4 Taylor polynomials, which is what the question asked us to do. Find the first 4 Taylor polynomials at x equals 1. And there they all are. How good are they? Quite good. You can actually do some evaluations. So this was at x equals 1. So at x equals 1.1, the ln of 1.1, the actual true value of ln of 1.1 is equal to 0.0953 10. So that's the actual value. P4, a 4th order polynomial of 1.1, would be putting 1.1 in all of that. So you'd have 1.1 minus 1 minus 1.1 minus 1 squared all over 2 plus 1.1 minus 1 cubed all over 3 minus 1.1 minus 1 all raised to the power of 4 all over 4. So these brackets, even if you did that as a bracket, it would be all 0.1. So this is 0.1 squared, 0.1 cubed, etc. And you get that value is equal to 0.953 0.095308. So that's a 0 there. Pretty close. So not too far out, because we've taken a point that's very close to our A value. A was equal to 1, so 1.1. What happens if you take a value away? So at x equals 8, now that's nowhere near x equals 1, but at x equals 8, the approximation P for 8 is equal to negative 503.4 blah 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 blah, but the ln, the natural log of 8, is equal to 2.079 whatever. So you can see that as you get away from our x equals 1, the polynomial is not a really good approximation whatsoever. Not good. But if you choose a point that's close to x equals 1, in this case 1.1, you get quite a good approximation. So that's the way to calculate Taylor's polynomials. Go through, you've got to be able to find your derivatives, you've got to be able to recognise what is the function, what is the A value, and then know the general rule for what the polynomials are, and then address the question as to which order polynomial you need to calculate.